Imagine looking through a telescope and spotting what appears to be a comet racing across space. It has a glowing head and a massive tail stretching for millions of miles behind it. But then, scientists realize something astonishing. It isn't a comet at all. It's an entire planet, and that planet is literally leaving itself behind. This isn't science fiction. It's one of the strangest worlds ever discovered by NASA and astronomers studying distant star systems. A planet so close to its own star that its surface is being vaporized into space, creating a giant tail visible across the cosmos. The planet is known as K222b, one of several rare disintegrating planets that are slowly destroying themselves before our eyes. And every orbit brings it one step closer to complete extinction. The mystery began when NASA's Kepler K2 mission detected unusual dips in the brightness of a distant star. Normally, when a planet passes in front of its star, the light drops by almost exactly the same amount every orbit. The pattern is predictable, allowing astronomers to calculate the planet's size and orbit. But this star refused to behave normally. Sometimes the dimming was deep, sometimes it was barely noticeable, sometimes the shape of the signal looked completely different. At first, researchers suspected instrumental errors. Maybe the telescope had glitched. Maybe another object was interfering with the data. But as more observations arrived, something extraordinary became clear. The planet itself wasn't changing. Its tail was. Instead of a solid world producing a clean shadow, enormous clouds of dust were drifting behind and sometimes even ahead of the planet. Those clouds constantly changed shape, making every transit different from the last. It was the first clue that astronomers weren't observing an ordinary exoplanet. They were watching a world fall apart. K222b orbits unbelievably close to its parent star. A single year there lasts only about 9 hours. Think about that. While Earth needs 365 days to complete one orbit around the Sun, this planet circles its star nearly 3 times every Earth day. At such an extreme distance, temperatures likely exceed 2,000 degrees Celsius, hot enough to melt and vaporize rock. Not ice, not water, rock. Scientists believe the surface is molten minerals. The intense heat tears atoms away from the planet, producing streams of vapor that escape into space. As that vapor cools, tiny grains of rock condense into dust. Those microscopic particles are then pushed away by radiation from the star, creating an enormous tail stretching tens of thousands, even millions of kilometers into space. It's remarkably similar to a comet's tail. Except comets lose frozen ice. This planet loses pieces of itself every second. Researchers studying the system noticed something even stranger. Unlike most comet tails, which trail behind because of solar radiation, K222b sometimes appeared to have dust extending in front of the planet as well. That seemed impossible. How could material race ahead of the object producing it? The answer lies in an incredibly delicate balance between gravity, radiation pressure, and the orbital motion of tiny dust particles. Different-sized grains respond differently to the star's light. Some spiral behind, others drift into positions that appear to lead the planet from our point of view. The result is one of the most bizarre transit signatures ever recorded. Every orbit paints a different picture across the face of the star. No two crossings look exactly alike. Astronomers quickly realized K222b wasn't alone. Another famous world, Kepler 1520b, showed similar behavior. It too appeared to be shedding enormous clouds of mineral dust as its surface slowly evaporated. Finding two examples suggested an entirely new class of planets, worlds that don't simply orbit their stars, they slowly evaporate under relentless stellar heat. These discoveries forced scientists to rethink how planetary systems evolve. We often imagine planets as stable objects lasting billions of years, but these worlds reveal a far more violent reality. Some planets spend their final chapters being ripped apart atom by atom. Every orbit removes more material. Every year makes them slightly smaller. Eventually, nothing may be remained except scattered dust orbiting the star. Yet another puzzle emerged. If these planets are disappearing so quickly, why are we lucky enough to observe them now? The disintegration phase may last only a tiny fraction of a planet's lifetime. Statistically, catching one in the act should be incredibly rare, unless this process happens far more often than anyone ever imagined.
The search through years of telescope data uncovered an important pattern. K2-22b and Kepler 1520b weren't isolated oddities. They belong to a small but growing family of planets orbiting so close to their stars that they exist on the very edge of survival. Every new discovery strengthened the idea that some rocky worlds end their lives not in a dramatic explosion, but through a slow, relentless process of evaporation. That realization raised an even bigger question. How long can a planet survive while constantly losing material? To answer it, astronomers built computer models based on the observed amount of dust escaping these worlds. The results suggested that the mass loss rate isn't always constant. It can increase or decrease depending on changes in the planet's surface, the star's activity, and even how much fresh rock becomes exposed. In other words, these planets may experience periods of relatively quiet erosion followed by bursts of much heavier mass loss. That explains why the dust tails appear to change from one orbit to the next. Sometimes the escaping material forms a thick cloud that blocks a significant amount of starlight. Other times, much less dust is released, making the planet appear almost invisible. Instead of watching a stable object, astronomers are witnessing an active geological process unfolding from hundreds of light years away. The dust itself has become an important scientific clue. By studying how different wavelengths of light pass through the tail, researchers can estimate the size of the dust grains and infer what they're made of. Evidence suggests the particles are likely composed of vaporized rock-forming minerals, such as silicates, the same kinds of materials found in Earth's crust. That means scientists are, in a sense, analyzing the remains of a distant planet's surface without ever seeing the surface directly. It's one of the few ways we can study the composition of an exoplanet that is otherwise too small and too distant to image. The planet's star also plays a crucial role in this cosmic drama. Stars constantly emit intense light and streams of energetic particles. At the extremely close distances where these planets orbit, that radiation is powerful enough to heat the surface beyond the melting point of many minerals. Gravity still holds the planet together, but only barely. As vaporized rock escapes, the planet slowly loses mass. If enough material is lost, its gravity weakens further, making it even easier for additional material to escape. It's a feedback process that can accelerate the planet's decline. Yet, despite this destruction, the planet doesn't disappear overnight. Even under extreme conditions, the process can take millions of years. To human beings, that's unimaginably long. To the universe, it's only a brief moment. We are observing a fleeting stage that relatively few planets may pass through before vanishing completely. These discoveries have changed the way astronomers think about planetary evolution. For decades, most attention focused on how planets form from clouds of gas and dust around young stars. Now, scientists are also learning how planets die. Some are swallowed when their stars expand into red giants. Some may be ejected into interstellar space through gravitational interactions. And some, like K2-22b, slowly dissolve into streams of mineral dust, leaving behind spectacular tails that can be detected across the galaxy. Future observatories are expected to reveal even more. NASA's James Webb Space Telescope and other advanced instruments are capable of studying exoplanet atmospheres and dust in far greater detail than ever before. By observing disintegrating planets at multiple wavelengths, astronomers hope to identify the specific minerals in their tails and better understand the physical processes driving their destruction. Each new observation turns these dying worlds into natural laboratories. They help scientists test theories of extreme planetary environments, atmospheric escape, mineral chemistry, and the long-term evolution of planetary systems. Perhaps the most remarkable aspect of this discovery is what it says about our own place in the universe. Earth orbits at a distance where liquid water can exist and where the sun's heat supports life rather than destroying the planet. But elsewhere in the galaxy, countless worlds experience conditions so extreme that mountains could melt, rocks become vapor, and entire planets slowly drift away as clouds of dust. The universe is filled with environments that challenge our imagination. A planet with a giant tail isn't a cosmic illusion. It isn't a comet masquerading as a world. It's a real planet undergoing a measurable, observable transformation, one that astronomers have detected using nothing more than tiny changes in the light of a distant star. Every transit captures another chapter in its final story. Every cloud of dust marks another piece of a once solid world escaping into space. Millions of years from now, that remarkable planet may no longer exist. Its rocky surface will have been scattered into the darkness, its orbit empty except for faint traces of dust circling its star. But thanks to NASA's Kepler mission and years of careful scientific observation, humanity has witnessed something extraordinary. Not the birth of a world, but the rare and haunting spectacle of a planet slowly disappearing before our eyes. And somewhere among the billions of stars in our galaxy, another fading world may already be leaving its own giant tail across space, waiting for us to discover it next.